Good afternoon. Good afternoon. Thank you for being here. My name is Haider Whitwood. I'm a Senior Solutions Architect with AWS Worldwide Public Sector. I've been with AWS for over 4 years now, with the last year dedicated on the VMware Cloud and AWS offering. Today, I'm joined by my colleague from VMware, Umair. I'll let you introduce yourself.
Hi, my name is Umair Ahmed. I'm a Senior Technical Product Manager from the Network and Security Business Unit at VMware. Last few years, I've been focused on multi-site disaster recovery solutions on-prem. I've since transitioned to a cloud, working on VMware Cloud and AWS. Very interesting. I look at the cloud just like another site, except now it's sitting in the cloud.
Thank you. Our session today is about the connectivity options of the VMware Cloud and AWS software-defined data centers. We call them short by SDDCs. And to set expectations, this is a 300-level session. So we expect you to be familiar with some of the AWS network capabilities, like VPCs, Direct Connect, route tables, our AWS Managed VPN offering, and also to be familiar with the VMware primary building blocks as well. So vCenter, ESXi, NSX, also to be familiar to really make the maximum benefit of this session. In today's session, we'll provide a quick recap of the VMware Cloud and AWS offering. We'll also go over the new networking and security capabilities of NSX-T, which is primary networking components that build out the VMware cluster on AWS. We'll also go over the connectivity options to native AWS services. And at the end, around the end, we will try to use the learning that we use from the session to see how we can meet the different connectivity requirements in a hybrid environments, where you have an environment running on VMware on premises, an environment running on VMware in the cloud, and also environment running on native AWS services. At the end, we will provide a live demonstration for sample workloads that we will migrate from an on-premises VMware environment to the VMware environments in the cloud over AWS Direct Connect. Okay, so let's get into it. The VMware Cloud and AWS offering is about enabling you to launch VMware clusters on AWS dedicated EC2 bare metal instances. These VMware clusters are powered by the VMware Cloud Foundation framework, which comprise out of 3 primary blocks, vSphere for compute, vSAN for storage, and NSX for networking and security. This cluster is managed by a dedicated vCenter that runs on the cluster itself. This is the same vCenter you know and you use today to manage your VMware environments on premises. This vCenter in the cloud enables integration with the vCenter on premises using hybrid link mode to enable you to have a single pane of management access for both your VMware environments on cloud and on premises. And because the VMware cluster on AWS runs on AWS infrastructure, that gives you rich integration options with AWS native services to enable you have both the capabilities of VMware platform and AWS platform when you design your applications in the cloud. From account structure perspective, there are 2 AWS accounts involved in every VMware cluster. The first one is created by VMware on behalf of the customer to host all of the AWS resources necessary to run that VMware cluster. So it's owned and managed by VMware as part of the VMware management model of the cluster, of the offering, and it's a single tenant, meaning this account is only used for one customer only. Every VMware cluster have an AWS dedicated connected account. So during the launch of the VMware cluster, you have to provide an AWS account, and in specific, an AWS VPC, where you will connect that VMware cluster with this AWS VPC for the purpose of enabling private connectivity between the 2 environments. So this AWS account is a standard AWS account that you own as a customer. It could be a new account or something existing account. And you, of course, have full access to this account, and you're responsible for all of the resources you build and utilize in that AWS account. Let's put that in a diagram. Every VMware cluster runs and provisioned in a single Amazon VPC. So that VPC of course, runs in the VMware managed account. And the first level of networking to touch on is the EC2 networking, the VPC level of networking that provide the connectivity between the host clusters. These are the ESXi servers that runs on the EC2 bare metal. The EC2 networking will provide connectivity between these cluster components. NSX will build overlay networks. And there are two types of overlay networks. The first one is the management network. And the purpose of this network is to provide connectivity to management components like vCenter. This network is controlled by an NSX component called Management Gateway. We call short by MGW. The second type of overlay networks are the compute networks. This is used to provide connectivity to your VMs. When you create a VM, you connect it to a network that resides on the compute networks. This one is managed by a different NSX component called the Compute Gateway, CGW. We called it short by CGW. Both MGW and CGW runs on a software router, NSX-T edge router. This edge router acts as a software router that provides the connectivity to the cluster from remote networks. This router utilizes an internet gateway that's associated to the VMware managed VPC. The purpose, of course, to provide public connectivity. This could be public connectivity to the management components like vCenter, or it could be the public connectivity to the VMware VMs that the customer create and choose to associate a public IP address to the overlay IP address. Remember, that's not the standard EC2 address, that's the overlay address provided by NSX. So that traffic will flow through the internet gateway. It's also utilize a virtual private gateway when the customer chooses to associate a Direct Connect, a virtual private interface with Direct Connect. You know that goes through a VGW. This is a VMware managed VGW that they associate to the VPC when a customer goes through the process of attaching a private VIF to my SDDC cluster. We mentioned that every VMware cluster associates to an AWS account and VPC to be more specific. So when you launch that cluster, you need to specify an AWS account and a VPC in the same region where you're launching that cluster. And the purpose is to create VMware endpoints, special VMware endpoints, to provide connectivity between the two environments. These endpoints are, in fact, elastic network interfaces that would be launched in a subnet that the customer chooses and will utilize an IP address from that space. And it will provide connectivity between all of the resources that's running in that AWS VPC with the VMs that runs on the VMware cluster. Software-defined data centers on AWS have two deployment options. You can launch a cluster in a single AZ mode. And in this case, all of the AWS resources to support that cluster will be launched in a single AZ. On the customer side, on the connected VPC side, you will have to specify a single subnet. And of course, you know, subnets live in a single AZ, where all of the VMware endpoints will be provisioned. Notice, although there are multiple network interfaces that we're showing here to support the multiple clusters, only one of them is really used at a time. And this will depend on the placement of the edge router on which ESXi host or host on the VMware side of the environment. The connectivity from the AWS side to the VMware is controlled by the standard AWS or VPC route table. So you can see in this screenshot that there are two logical networks on the VMware side that are listed in my route table with a valid target to be that network interface, that ENI. The second deployment option is a stretch clusters or multi-AZ clusters. In this case, for high availability, you have the option to launch your VMware cluster across two availability zones. In this case, the number of hosts will be equally distributed across the two availability zones. And vSAN will provide synchronous replication for all of the data across the two AZs. On the AWS side, you'll need to specify two subnets in two different availability zones to host your VMware endpoints. Still with this model, you have a single edge appliance that lives in one of the availability zones. In the event, if the AZ becomes unhealthy, VMware will use vSphere HA, high availability, to automatically stand up the management component, the VMs from the unhealthy AZ to the healthy AZ, and automatically update the route table on the AWS side using AWS APIs, utilizing an IAM role that's created during the launch of the cluster. The purpose, of course, to maintain connectivity after failover. Okay, now I'm going to hand it over to Hamer to go over the connectivity features, the new features of NSX-T.
Great. Thank you, Haidar. So what I want to do in this section is I want to cover all of the networking and security provided by NSX in VMware Cloud on AWS. Now, many of you may already know, when we launched this service, VMware Cloud on AWS, the underlying networking and security stack was NSX-V. And what we did is we changed that underlying platform to the new NSX platform, NSX-T. And if you take a look at it, you can see there's some similarities here. You still have a single CGW where all your compute workloads sit behind. You still have a single MGW where all the management components sit behind that VMware manages, okay? And when user creates a network segment or logical network, it's automatically connected to the CGW and the routing information propagated up, okay? Now, there are some key differences as well. First, the CGW and MGW are no longer VMs. They're actually logical entities sitting within one edge appliance. And we have an active edge and we have a standby edge, okay? Another difference here you'll note is they're connected together via a tier 0 router. Sorry. They're connected here via this tier 0 router, okay? So basically all these components sitting behind the CGW or all these workloads now have access to the management component sitting on that vCenter management network. And the other difference here is this edge is DPDK based, giving us better overall performance. Also, you'll note the vCenter management network is now also on an overlay similar to the compute workloads. So it's giving you that same operational model, all right? Now, the CGW and MGW in NSX-T terminology are known as T1 routers. This edge router is known as a T0 router. The T0 router has connectivity to all the external environments. Okay, your internet connection terminates there, Direct Connect, VPN, so on. The CGW, MGW are tier 1 routers. It has an edge component that sits in this appliance and also has a distributed component across all the hosts. The distributed component you can think of similar to the distributed logical router in NSX-V. It's the gateway for the workloads, the gateway for the VMs. Okay? Now, taking a quick look at the GUI here, you'll note under networking and security, quite a bit of things have changed as well. We've moved the entire menu to the left. A lot of good feedback from customers on making this easier to use. You'll see there's groupings there, network, security, inventory tool system, and the respective features and configurations in each of those sections. Now, key thing to note here is there's a lot of capabilities and features you get for free with NSX and VMware Cloud on AWS. You get networking, security edge firewall, grouping objects, some operational tools like port mirroring, IPFix I'll cover later. And then there's an advanced services add-on as well, which includes things like distributed firewall, which is available now, service insertion in the future, and load balancer in the future. So this advanced services add-on is a paid feature, but it will include all of these features. Initially, this distributed firewall is a free trial, and when we enable the add-on functionality, this will be a paid feature. Okay? So now moving ahead quickly here to some of the new capabilities and features provided by NSX-T. One of the biggest requests from customers was this ability for microsegmentation with distributed firewall. Okay? So now customers can get granular stateful firewall at the VM level, and they can do microsegmentation within the same L2 domain and also across different networks. Okay, also, customers can create multi-tenant environments, although no overlapping IPs because you're still connected to the same CGW, but you can put now a tenant on a different network segment and use distributed firewall to provide that isolation, okay? You can easily isolate networks like prod, test, dev, can easily create DMZ environments using this micro-segmentation capability. And most importantly, customers can now migrate to the cloud and get that same level of security that they're used to on-prem. So customers who have NSX on-prem, who are using grouping objects, security tags, micro-segmentation with DFW can now move to the cloud and have those same types of capabilities available. Grouping objects goes hand in hand with DFW. You can create groups based on different matching criteria. You can use IP address for the matching criteria. You can use VM instance where you just select the specific VM. You can use VM name, something like, hey, all VMs that have a name that start with WEB or web put into this security group automatically. You can use security tags. All VMs that have this specific security tag, automatically add them to the security group, right? And then you can use these grouping objects in security policies. You can use them both in DFW and also on the edge firewall. So this is a very important feature, a big ask from customers. Customers want to move away from using IP address and security policies. IP addresses have no context in terms of the application, right? So they want to use some type of metadata or something closer to the application, like VM name or security tag. And if the IP address changes, it doesn't matter because the policy doesn't rely on the IP address. A lot of enhancements in terms of connectivity as well. First, you'll remember in NSXV, we supported IPSec VPN policy-based, IPSec VPN, okay, where you had to select the networks on each side. Now we also support route-based IPSec VPN, where you can set up IPSec VPN, and then you can run BGP over it to automatically learn the networks, okay? And you'll notice here it's a single VPN tunnel design. In NSXV, since we didn't have a router connecting the CGW and MGW, you would have to create a VPN to the CGW and MGW. Now you can create one VPN to this tier 0 router, and it knows how to reach the networks behind the CGW and behind the MGW. So here, I've created the IPSec VPN, then I go to my VMware Cloud on AWS console, and I create this virtual tunnel interface. What happens there is it creates a loopback address on the tier 0 router, which then I can use for the BGP peering to on-prem. So not only do I get this automatic learning of networks, but I can also leverage this for resiliency. So I have this single IP address here on this tier 0 router, and I'm peering with 2 different devices edge devices on-prem, okay? And what I did here is I created 2 different virtual tunnel interfaces on the tier 0 router, set up BGP on both of them, and both of these tunnels are active, but I can control the path used via BGP metrics like BGPS path prepend or MED and so on, okay? Now, one thing to note here is I can use both public or private IP address. This tier 0 router has a public IP address. It also has a private IP address. So I can do IPsec VPN over internet, or I can also do it over Direct Connect using the private IP address. Why might I want to do that? Well, maybe I have a requirement to encrypt traffic that's going over Direct Connect. Okay. So once this is set up, the entire VPC CIDR is advertised on-prem, including the management appliance network and the NSX network segments. And then vice versa, on-prem networks are advertised to VMware Cloud on AWS SDDC. Direct Connect, we also have a lot of enhancements here. So you'll remember in NSX SDDC, we supported only ESX management, vMotion, and cold migration traffic over Direct Connect. Now, with certain types of traffic like compute traffic and management appliance traffic with the NSX SDDC, we had to set up a VPN over internet or VPN over Direct Connect public WIF. Okay, so there was some complexity involved and wasn't really the ideal design. Now we can support all traffic over this at a Direct Connect private WIF terminating directly into the customer VPC. And how we did that is, before there was an issue when the traffic was being sent to these workloads sitting on NSX segments, it would hit this VGW, and it wouldn't know how to reach these overlay networks. Now we have a process running here that updates this VGW's route table to tell it how to reach these overlay networks to support all traffic over Direct Connect private WIF. And again, entire VPC CIDR is advertised on-prem once this is set up, and management appliance networks and also NSX network segments are also advertised on-prem, and vice versa from on-prem, networks are advertised to the SDDC. Okay? Now, although not a new feature, I want to mention L2 VPN here since we're talking about connectivity. We also support L2 VPN. So similar to VMware Cloud on AWS, you can have NSX on-prem, but it's not a requirement, right? In this example, I don't have NSX on-prem. And what I did is I downloaded the NSX standalone client, okay? I have the server running in VMware Cloud on AWS. I come here, I set up an extended network, gave it a tunnel ID of 50, matched it on the client, and set up my extended network. One thing to note here is with L2 VPN, the gateway is always on-prem. Okay, when you set up a routed network, the gateway is always that tier 1 router or the CGW. When you create an extended network, it's always on-prem. And how we see customers use this is they'll set up extended network, they'll set up L2 VPN, and they'll migrate their workloads to the SDDC. And once that migration is done for that subnet, they'll switch that extended network to a routed network, which at that time the gateway will become the CGW or the tier 1 router there, okay? And again, similarly here, we have both a public IP address and private IP address on this tier 0 router. You can use either one. So you could do L2 VPN over internet, or you can do L2 VPN over Direct Connect. However, I should mention, if you're trying to do vMotion in conjunction with L2 VPN, we only support vMotion over Direct Connect, okay? Now, a couple additional enhancements in terms of connectivity. As I mentioned earlier, we now support connectivity for workloads beyond CGW to the management appliances behind the MGW, right? We have that connectivity to the tier 0 router, so we can call vCenter APIs, or I might have some application that needs access to vCenter. This is now possible. Similarly here, vCenter management network is also accessible from connected VPC. We update the route table here in the connected VPC to not only reach the compute networks, but now we also update it so it can reach the vCenter management network as well. And why might you want to do this? Again, you might be calling vCenter APIs, or you might have some application that needs access to vCenter. You can run those now on EC2 instances. Okay, moving ahead quickly to operations. We now support port mirroring and IPFix. So I can actually set up port mirroring in VMware Cloud on AWS. Pretty cool stuff. So in this example, I have a workload here in VMware Cloud on AWS, which is talking to an EC2 instance, okay? And what I'm doing is I've enabled port mirroring so that traffic bidirectionally is being sent to Wireshark, okay? And this is possible now because this tier 0 router is connected to the MGW and CGW. And the ESXi hosts are connected to MGW, so that port mirroring information can be sent up towards the T0 router to the CGW, and in return to the appliance sitting on NSX network segment. So here you can see in VMware Cloud on AWS, I've actually created a session, and the source is Web Security Group, has that Web VM as a member. Destination is Wireshark Security Group, has Wireshark as a member, and I've set up bidirectional to send that, enable the port mirroring, okay? Similarly, I can do this for IPFix. I can have something like Plixer Scrutinizer running on a network segment. I can come here and set up a collector. This is the IP address of that Plixer Scrutinizer. And then I can set up a session. You can see the segment is the web NSX network segment. So I'm setting IPFix data to that appliance sitting on a NSX network segment, okay? So pretty cool stuff in terms of operations, and just a couple other additional features here. I really focused on connectivity and security. Just briefly, I want to mention, we also now can create network segments from the console. You no longer have to go into vCenter. We had an NSX plugin there where you had to create the network segment there. Now you can do everything from the console, including creating the network segment. We now support multiple DNS zones. Prior, we only could add 2 DNS servers. Now we can create multiple DNS zones and multiple DNS servers per DNS zone. We also have RBAC capability, so we can enable read-only access or read and write access to the networking and security tab. And finally, NSX-T APIs. We have public and private endpoints. So I can call NSX-T APIs using a public IP address, or I can set up something like Direct Connect VPN and use private endpoint to call the NSX-T APIs. Okay? So a lot of stuff there, and I really focused on connectivity and security, and then talked a little about operations. So what I want to do here is I want to talk about some of the security considerations when you're talking about connectivity. Okay? So first I want to focus on edge firewall. And let's talk about CGW firewall first. So CGW firewall, we actually don't implement it on the CGW. We implement it on the tier 0. And I'll tell you why in a minute here. Let's say I have a web server sitting behind the CGW, and I want to block all communication from the internet, but I want to allow communication from on-prem over Direct Connect. Because we're implementing it here on the tier 0, I can selectively place those firewall policies on the interfaces I want, like Direct Connect, Internet, VPN, and so on. Okay? If I had implemented it here, I would basically be blocking all the traffic to that web server. In addition, let's say I have a monitoring application here that needs access to my vCenter sitting behind my MGW. I want one centralized place to control access to my management components sitting behind MGW. So here, because I have no firewall policies on the actual CGW, the traffic comes here, hits the CGW, goes to the tier 0, comes down to the MGW, and I have one centralized place to control all access to my vCenter management components. Okay? Now let's talk about internet access and security. So one thing to note here is by default, all VMs already have source NAT and internet access by default. Think of your company, right? You have internet access, IT has already set it up for you. By default, you have that. Same thing in VMware Cloud on AWS. The workloads already have access by default because source NAT's enabled to the internet. Now, obviously, to provide a secure environment, we block that on the edge. But if you want a specific workload to have internet access, you can just come here to the edge and allow that traffic through. Now, you may also have web servers sitting behind this CGW where you want to give access to external clients, right? You can also do DNAT. You can configure DNAT for incoming traffic. A couple things to keep in mind here. When the traffic comes in, it hits DNAT, edge firewall, and then the routing happens. And same path, reverse, right? So because of this, you have to keep in mind when you're putting in security policies, edge firewall rules, DFW firewall rules, you want to use the NATed private IP addresses, okay? So a lot of things we covered there. I really focused on connectivity and security and talked a bit about operations, but you got a good glimpse of all the new NSX capabilities. Now I'm going to hand it back over to Haider, who's going to go into more detail on how you can leverage these capabilities and also talk about advanced designs and architectures.
Thank you, Amer. So in this section, we will discuss your integration options between your workloads running on the VMware side of the environment with your native AWS services or workloads running on your native AWS services. And for the purpose of this conversation, we'll really break down this to the two primary access models to AWS services. Privately, meaning you don't need an internet gateway to get to the service endpoint, or publicly, which means that you do need an internet gateway to get to the service endpoint. And what that basically means that the service endpoints is resolved to a public IP address, and that's why you need the IGW. In the public model with VMware and AWS, you're already within AWS network. So your VMware cluster, your VM is on AWS, and the service is on the same network on AWS. So the connection is already optimized from perspective of low latency, high throughput, high bandwidth. And so that's why we're not going to focus on that piece during this conversation, and our focus will be on the private connectivity model. And for this part, we'll break down to 3 groups. Depends on the service support model. The first one is gateway endpoints. And if you remember, like the first version of VPC endpoints that we started to add support to a while ago, it was two primary services that we enabled with gateway endpoints. It was S3 and DynamoDB. And the way this works is that you have a special gateway that you put in the route table of your VPC, and this gateway will get you to the service. No need for IGW, no need for NAT. At that time, it was NAT over EC2 or NAT gateway now, but there's no need for all of that. You get to the service from there. With VMware and AWS, only S3 service is supported with this model, and it's already baked in, meaning it's already engineered to give you the option to choose how your traffic to S3 is routed. And of course, this is from within the same region. So this is S3 bucket and resources within the same region where your VMware cluster is running. If you choose to enable S3 access from the VMware portal, your traffic will be routed through the VMware endpoint in the connected VPC, goes through the S3 endpoint and then to the S3 service from there. The benefit of this model is that you get a better security posture, of course. You can write down bucket policies that limit access to only from the S3 endpoint. It works better when customers have requirements to only use customer-managed internet gateways. However, if you don't want to route that traffic this way, or if you don't have an S3 endpoint, you can actually choose to disable that feature from console, from the VMware portal, and then your traffic will be routed using the standard internet gateway that's associated to the VPC where your VMware cluster is running. The second group of services are services that have support for private link powered interface endpoints. And this is the version 2 of VPC endpoints. And if you've been tracking the announcement, you're going to see that majority of AWS services are either like added support or in the process of adding support like to the private link. In addition to AWS services, you will also have the option to enable access to like services built on EC2. You can build a TCP service on EC2, and depends on the traffic flow. If the traffic flow is from the consumer to the service, right, where the consumer always initiate the traffic, the service never initiate the traffic, it's only return the request or the response for the request, this could be a good candidate for a private link power service. So this is something that you can do within your existing AWS account, across AWS accounts. Partners are doing that as well. And the last really kind of option or group is the marketplace products. Now there is a good number of SaaS products in the AWS marketplace that are offered over private link. So let's refresh our information on how private link works. You have the concepts of a service provider VPC. This is where your service is running. And in this example, using AWS Systems Manager. The service runs behind a network load balancer, which is a TCP load balancer. That load balancer will have an interface endpoint in a consumer VPC. This endpoint will utilize an IP address from the space of the consumer VPC. And the service, in the case of AWS services, you can either choose a special DNS endpoint URL, or you can use the same default endpoint or service URL. For the endpoint. So that's kind of an optional thing that you can enable. However, to really resolve that name to the private IP address, you have to make the call from within the VPC where you have the interface endpoint. And specifically, you're basically addressing the VPC resolver that we usually call the .2 address, the .2 DNS resolver. When we map this to the VMware model, there are really two primary things that you need to plan for. First thing is that you create your VMware endpoints in a VPC that has the interface endpoints so that you have the local connectivity in between the two. Second thing, you need to plan for name resolution so that when you address this endpoint, it will get resolved to the private IP address. And for that one, you have few options. In the past, we used to say, use DNS forwarder, like launch an EC2 machine, put DNS, and use this DNS for your VMware VMs, and then configure that DNS server to make these calls to the .2 resolver. In this case, you are really kind of initiating the request to the .2 from locally within the VPC, and that's how kind of you make it work. That works. However, since last week, we announced a new feature with Route 53 called Route 53 Resolvers that will enable you to create DNS endpoints inside your VPC and use it for your name resolution. Locally, you can configure it to go and kind of make conditional forwarders to like external domains on premises. It's all really kind of optional and configurable for you, which means that now we have the option of a managed DNS endpoint that can do these calls for us. So once you kind of meet these two requirements, your traffic, when you access the endpoint from your VMware VMs, your traffic will be resolved. The name will be resolved to a private and then IP, and then after that, the traffic will flow through the VMware endpoints and then the interface endpoints through NLB to the service. The last group of AWS services are really services that create an endpoint inside your customer, your VPC. And maybe the most common example for this service is RDS. When you create an RDS instance, you specify your VPC, and you will have an endpoint, a database endpoint that utilizes an IP address from your VPC space. To leverage RDS from your VMs, VMware VMs, just make sure that your RDS endpoint is provisioned in that VPC where you have your VMware endpoints, and that's pretty much it. You can access the service, the endpoint directly. Same thing with EFS. EFS allow you to create mapping points in your VPC in every subnet or logical or AZ that you want to leverage the service. And in this case, you can use the same model and have the EFS mapping points in your connected VPC and map and add these mapping points directly to your VMs if you want to leverage a managed file service. Another example, Workspaces. Workspaces, as you know, the workspace itself runs in an AWS managed VPC. However, it has two interfaces. The first one is ETH0 for management, for the purpose of streaming that session over public internet. It's an encrypted session, but it goes to the ETH0 interface. You don't manage that interface. However, what you control is the ETH1, and ETH1 is the data interface. This is where you control to put in your VPC. The purpose is to manage connectivity to your local resources. So these local resources can be in the same VPC or can be somewhere else. And you will use the routing table capabilities and AWS capabilities to route that traffic. So assume you have a data point that's on premises. You can have a direct connect to your VPC, and then your traffic will flow through that direct connect to your data set on premises. Taking this model, map it to the VMware on AWS, you can simply extend the connectivity to your VMware workloads by just having that VMware endpoints in the same VPC where you have your ETH1. Last example, application load balancer. ALB, as you know, support IP-based targets. These are private IP addresses where the ALB can talk to. When you launch your ALB in the connected VPC, your traffic can go through the VMware endpoints to your VMware VMs. Not just the ALB features now are available for you to use that as an entry point for your VMware applications, you can also use ALB capabilities. You can do SSL offloading using integration with ACM. You can use WAF since it integrates with ALB. You can start to plan for DDoS mitigation using Shield Advanced. So all of these options are available for you now because you're using ALB. We have talked about a lot of options, right? A lot of capabilities. Now let's take it into action. We're going to make this as a practice. Let's assume you are the network engineer. You are responsible to provide connectivity, and you have a business or a different engineering department that put out requirements for you to go and meet. So we'll start this with a single SDDC, right? We'll call it SDDC1. This SDDC1 has a connected VPC1. Of course, connected VPC means the VPC where you have your VMware endpoints, and you have a customer on a premises data center. First requirement we got is they wanted to enable connectivity between SDDC1 and on-premise. Obviously, you have two options here. The first option is if my on-premises site has internet, I'll just create a VPN, right? I'll create a VPN using the public IP address of the NSX edge and the public IP address of my edge router on-prem. That's option. Second option is I know now with NSX-T I have full DX support with private VIF. So if it depends on the throughput requirements, latency requirements, I can actually provision an optimized connection at a lower data transfer rate as well with Direct Connect than routing traffic over internet, and use Direct Connect. I'll create a private VIF associated to the SDDC that will take care of routing both the management traffic and the compute traffic. So we got this one checked. Next requirement we got is that we have a set of services that runs in a shared services VPC. That shared services VPC have services that need to be utilized from VPC 1. So they already created the peering, right? And they said, we also need to access these services from SDDC, like VMware workloads running in SDDC. Go and figure it out for us. If you think that you can route the traffic through the peering, through the VMware endpoints, to the SDDC, you are mistaken, because that'll be transitive routing. And transitive routing is still not supported with VPC, right? So that's not an option. That's not going to work. The easiest option is create a VPN connection between your shared services VPC using our managed VPN, VGW, to the public IP address of your NSX edge, right? You're good to go. Next requirement is, we are growing this environment, and now we have another SDDC, SDDC2 connected to VPC2, and now we have a similar access requirement like SDDC1. So to on-premises, I already have DX. I'll just create another private virtual interface. I'll associate it to my SDDC2 that will take care of the on-prem part. For the shared services, I'll just mimic the same model, right? VPN connection, we're good to go. They come back and say, those two SDDCs cannot talk to each other. Right, they cannot talk to each other. And if you need that, the simplest, maybe the most direct option is, let's just create a tunnel between the two public IP addresses of the two edges, and that will enable routing for us. Next requirement is, these VPCs also need to talk to on-prem. OK, no problem. Direct Connect Gateway. Direct Connect Gateway can associate to multiple VPCs, up to 10 VPCs. We'll create a private VIF, associate to the DX gateway, and then create association from the DX gateway to my VPCs. Important to know, DX gateway don't have support yet or currently with SDDCs. That's why we didn't have that option for our SDDC part of the connection. It's only available to my VPC side. OK, now it's getting serious. The team needs to understand the resiliency of our connections. They come back and said, we are building SLAs. We want to make sure that you guys don't have single point of failures. OK, let's revisit some of the stuff that we did. For the VPN connection between my VPC using VGW and SDDC, it's using our AWS managed VPN. And I know with every VPN connection, you get 2 public endpoints. So we just need to make sure that we have 2 tunnels up, and BGP will take care of picking the active one. However, I have 1 edge on the SDDC side. So is there a single point of failure here? Answer is no, because NSX by design, the NSX edge, runs in an active standby configuration, meaning there is an already standby router sitting ready with all of the necessary configuration to kick in if necessary, and we'll just pick up all of the VPN configuration. Learning that means I'm also covered with the VPN tunnel to my other SDDC, because there is already redundancy on that other part. Although it's a single tunnel, it's redundant on the edge side. OK, so we seem to be OK from a VPN perspective. What about Direct Connect? Direct Connect, I have a single circuit. And that means if this connection is down, I will lose connectivity to my on-premises. And for that, to meet the best practices of Direct Connect, I'll just have to create another Direct Connect circuit. With a new circuit, I need to create a new set of virtual interfaces. And I'll need 3 in this model. I need 2 of them to go to every SDDC, and I need only 1 to go to DX Gateway. And DX Gateway is already highly available by design. So we feel good at this point once we added the second circuit. Next requirement came from the team is encryption. They need to make sure that traffic between SDDCs and on-premises is encrypted. We have learned from the information today that I have two options. Reason is because the NSX Edge gives you the option to use a private IP address or a public IP address. So if I choose a private, and I already have a private interface, private Direct Connect interface, that means that if I create a tunnel using that private IP address, my tunnel will be routed over the private VIF. Cool. However, there is a question. We also learned that Direct Connect supports full routing, meaning these networks already routed using BGP over private VIF, which means that these networks will be advertised twice, once over the private VIF BGP and once over the VPN BGP. So which one of them is going to take over? The answer is VPN. In the VMware model, VPN take higher preference than BGP over private VIF, which means I'm good. I can pick up the tunnels, the networks that I want to encrypt, and the tunnel will be routed over private VIF, and the BGP route learned from VPN will take over. Because I also have public IP address, and because this public IP address is really provided by AWS, meaning it's from within the AWS public space of the region, I can actually also use public virtual interface. And if I create the tunnel using this public IP address, my tunnel will be routed over the AWS public backbone. And this model really works well when there is an overall encryption requirements, and which means that I also need to create tunnels to my VPCs, and preferably I always use my VGW that use a public IP address. So I'll just use that same model, and stay consistent. To add the resiliency requirement, I need to create 2 tunnels for every site across 2 different Direct Connect circuits. Man, I know what you said. This is getting ugly. A lot of tunnels, right? This is challenging. OK. So the next requirement is scalability. They wanted really to make sure that this environment is scalable from management perspective because they expect the environment to grow further in the next few months. So maybe this is the time to go back to the whiting board and maybe switch from this decentralized model where I have a lot of tunnels. I can see that there is a serious challenge from a management perspective because I'm managing a lot of connections. So maybe this is the right time to change approach. And with changing approach, I can switch to a hub and spoke model. I know a lot of people have been using transit VPCs, right? So I'll use the same approach. I'll have transit VPC, which basically works by creating VPN over an EC2. You can choose the VPN software that you prefer. You can put it on EC2 and then create tunnels between these different environments to your router that will run on EC2. And in this model, I'll be able to control traffic between SDDCs from that router, VPCs, like VPC1 to shared services, VPC to SDDC as well, and the traffic to the on-prem as well can be controlled from that router. Interesting to mention is that although this model works fine right now, we expect some improvement in this space. So there are things coming that I cannot really talk about right now, but I encourage you to stay tuned for some new announcement in the near future. And since we are discussing scalability, right, let's revisit some of these services. Maybe there is another way to do things. If the services in shared services VPC are TCP services that need to be accessed from the consumer to the server, to the service itself, maybe this is a good candidate for a private link. And in this case, I'll just have an NLB in front of my servers. I'll have an endpoint, private link endpoint in my connected VPCs, manage the name resolution as well, using the options that we discussed. And when I access these services now, my traffic from my VMware VMs will go through the VMware ENI, through the private link endpoint, the network load balancer, and my services instances. With this model, I no longer need VPN connections. I no longer need peering. The private link endpoints are connected to the NLB by design. We don't need to plan for that. And this model is really scalable, where this shared services VPC can actually support thousands of consumers' VPCs, right? So some stuff to think about around areas of improvement. Cool. So in this section, we will switch to our lab environment to do the demo that you promised you with the migration from on-premises to migrating a sample workload from the on-premises VMware environment to the cloud. I'll just need a second here to connect to my lab environment. OK, good. So what we have here is a vCenter configured in hybrid link mode. So I can really see two views. I can see the view in the for the first vCenter is the vCenter in the cloud. The second vCenter is the vCenter on premises. I have this machine. I have this WordPress machine. That's a VM with WordPress running on it. I'll grab the IP address of the machine. This is an IP address ending with 1045. This IP is really accessible from my demo machine. And as you can see, this IP address is really mapped to a URL for my WordPress site. This URL is also accessible from my demo machine. It's currently running on premises, as you can see. And also to add to the experience, we have a load testing server that is generating requests per second for that website. And I'm going to track all of these metrics while I do the migration. So let's start the migration. If you're familiar with vMotion, the process really goes through choosing the destination. And in this case, since I'm moving to the different site, means I'm changing both the storage tier and the compute tiers. Next. I'll choose the vCenter in the cloud. When I expand this cluster, I can see that I have 6 nodes. That's a stretch cluster. So you have the first 3 nodes in US East 1B, and the rest is in 1C. So that's the stretch clusters that have nodes across 2 availability zones. I'll choose the resource pool for my destination. Choose the data store, which is my storage container folder for the destination machine. And then this is the part of that needs the stretch network. And one of the primary benefits of doing the vMotion is that you're maintaining the IP address of the machine. So we need an L2 stretch network to do this migration if we needed to maintain connectivity to the machine during migration. So schedule this migration, finish, start the migration. So we have a progress bar below for our migration. During this migration window, we will also ping that site or the machine and keep that running. We will also go to we'll also view our load testing tool that's generating requests per second. So right now, I'm sending about 7 requests per second, and the machine is being migrated as we speak. We have that progress bar. To tell you a little bit about this environment during this migration, the on-premises facility is in East 1, is in north of Virginia area, and the data and the VMware cluster is in US East 1. So there is around 20 to 30 miles in between. We have a direct connect circuit in between. The Direct Connect circuit is a 10 gig circuit. And by the way, my migration just completed really. If you say tracking, there is a single request that's timeout during the cutover. I'll maximize maybe my load testing tool. As you can see here, there is also a response time that was increased during the cutover window. However, there were 0 failures during the cutover time. Let's revisit the vCenter environment. I know I took the machine from on-premises. I put it in cluster 1 under this resource pool, reinvent demo. That's my machine now in the cloud using that same IP address, right? And this site should still be accessible. Okay, it is there. One thing that to mention here is that latency had a bit increase when we switched to the cloud. And of course, that makes sense because originally it was in the same site. We were pinging the machine. And then after that, the ping actually goes over Direct Connect. You can see that it's really consistent. And that's what we get with the optimized network experience with Direct Connect. OK, so switching back to the presentation. Nice. We talked a lot about networking. However, VMware and AWS has a lot of other areas to cover. If you have an interest in the topic, there are other sessions that are scheduled today and during the rest of the event. We encourage you to attend. Thank you very much for attending our session. We are really interested in your feedback. Please don't forget to submit feedback through the app. Thank you very much.